Now the question is, what is the unit of del cross H is? Option A is ampere, option B is ampere per meter square meter, option C is ampere per meter square, option D is ampere meter. See, according to Ampere's law, the formula is del cross H is equal to J, which is current density. So current density unit will be amperes per meter square. So option C will be the correct answer. Okay, one of the previous AES question, this one. Next. Which of the following field equation indicate that the free magnetic charges do not exist? Option A is H bar is equal to 1 by mu del cross A. H is equal to line integral IDL cross R bar by 4 pi R square. Option C is del dot H equal to 0. Option D is del cross H equal to J. Right? What is asking? Free magnetic field magnetic charge does not exist. See, we have the Maxwell equation, which is del dot B bar is equal to 0, which tells that there is no magnetic monopole exists in the Gauss law. Right? Magnetic monopole does not exist. So from this we can say free magnetic charge does not exist. So I can write this as del dot H bar is equal to 0. So option C will be the correct answer. Okay, if you see the remaining options, option D is del cross H equal to J is the Ampere's law. Option B is this is the Bayard-Savart's law, and option B is option A is it is B equal to del cross A, which is magnetic vector potential definition. So among four, option C will be the correct answer, which tells that there is no free magnetic charge exists. Okay, next question is, match the list 1 with list 2 and select the correct answer. So in the list 1, it is given some right formulas, and in the list 2, the formula name. Okay, option A is curl of vector equal to 0. See, curl of a vector field is 0 means it is irrotational. Right, so option A is 2. Divergence of vector field is 0, which is solenoidal. Right, so B is 3. And divergence of gradient of a scalar field is 0, which is Laplacian equation. And fourth one is divergence of scalar field is 0, which is not defined. Right, so by seeing this, option A will be the correct answer. Right, if you see the options, A is 2, B is 3, C is 1, D is 4. Okay, so what is A? A is 2 means curl of a vector field is equal to 0, which is irrotational. So A 2. B is divergence of vector field is 0, which is solenoidal. So B is 2. Divergence of gradient of a scalar field is 0, which is Laplacian, option A. And divergence of scalar field is not equal to 0, which is not defined. So among four, option A will be the correct answer. See, this one also previous IES question. Next, one more match the following. Match the list 1. List 1 is given with a lower quantity and with list 2, which is mathematical expression, and select the correct answer. So what is the first law in the list 1? Gauss law, Ampere's law, Faraday's law, Poynting vector. The right side will have the mathematical expressions. So Gauss law expression is what among 5? We can say del dot D equal to rho, which is the Gauss law. So option A will be, for A, option 1 will be the correct answer. Second is Ampere's law. For the Ampere's law, fifth option is correct. Del cross H equal to Jc plus dou D by dou T. Faraday's law. Faraday's law, del cross E equal to minus dou V by dou D. Pointing vector. Pointing vector is vector power is equal to E cross H bar. Right? So option is which is the correct option now? See, for A, Gauss law is 1, Ampere's law is 5, Faraday's law is 2, Poynting vector is 3. So 1, 5, 2, 3. Where it is in the option 3, you can see 1523. So option 3 will be the correct answers. Okay. Next question is 15th question. The Maxwell equation del cross E equal to minus dou v by dou d is represented in integral form is. See, del cross E equal to minus dou v by dou d, it is in Faraday's law. Okay. So Faraday's law, how it is represented in integral form is asking. So it is line integral, closed line integral equal to open surface integral. So out of 4, the second option will be the correct. Closed line integral E bar dot dl equal to minus dou by dou d of open surface integral B bar dot ds equal to 0. So option B will be the correct answer. This is the Faraday's line integral form. Okay. Thank you.